I'm going to keep this straightforward. If you've been scrolling through endless specs and wondering whether the Livox Avia is really worth the slot in your budget, this is the review that will help you judge the real value, the practical use, and whether it actually fits the work you need to do. Link is in the description if you want to check the product details on Amazon. First, let's talk about the hesitation most buyers feel. A LiDAR sensor that promises a 450-meter detection range and 240 points per second sounds impressive, but you're also buying a piece of hardware that has to integrate with a drone, a data pipeline, and often a whole suite of mapping software. The cost isn't just the unit price, it's the extra processing power, the need for a stable mounting solution, and the learning curve of setting up dual scanning modes. If you've ever tried a new sensor on a drone and found the data noisy or the firmware finicky, you know that the risk of buying the wrong thing is real. That's why I spent time looking at how the Avia actually performs in the field, not just on the brochure. Livox positions the Avia as a smart city and mobile mapping ready sensor. In practice, that translates to a few concrete scenarios. Imagine you're a utility company needing to inspect power lines stretched over rugged terrain. You launch a quadcopter equipped with the Avia, fly a pre-programmed corridor, and the sensor captures a dense point cloud out to 450 m. The triple echo return means you get first, second, and third bounce information, which is valuable for distinguishing thin wires from surrounding foliage. In a trial I followed online, a team used the Avia on a DJI Matrice 300 to map a 5-kilometer power corridor in under an hour, then processed the data to flag vegetation encroachment. The lightweight 498G form factor meant the drone could still carry enough battery for a decent flight time, and the IP67 rating gave the team confidence the sensor would survive a sudden rain shower without a hiccup. Another real-world use case is urban mobile mapping. City planners often need high-resolution 3D models of streetscapes, and the Avia's non-repetitive field-of view 70.4 by 77.2 helps capture more of the scene per pass compared to a traditional rotating LiDAR. A small mapping startup I read about paired the sensor with a fixed-wing UAV, covering a 10-square-kilometer district in a single morning flight. The 240 points per second rate gave them a dense enough dataset to extract building facades, road markings, and even sidewalk curbs without having to run multiple flight passes. That efficiency is where a lot of the value lives. You're not just paying for range, you're paying for the ability to finish a job faster and with fewer flight batteries. So who should buy the Livox Avia? If you're a professional surveyor, a utility inspection team, or a mapping company that already has the software pipeline to handle high-density point clouds, the Avia slots in nicely. Its long detection range is most useful when you need to see far-away features, think power lines, bridges, or tall structures without having to get the drone dangerously close. The dual scanning modes, a standard mode for general mapping and a high-density mode for detailed inspection, give you flexibility without swapping hardware. And because it's built to a rugged IP67 standard, you can plan flights in less than ideal weather, which is a real cost saver for field crews. On the other hand, if you're a hobbyist drone pilot who mainly shoots video, or you're experimenting with LiDAR for the first time on a weekend project, you'll likely find the Avia overkill. The sensor requires a fairly robust onboard computer to process the 240 points per second stream, and that adds weight, power consumption, and expense. Without a dedicated processing board, you'll end up with a bottleneck that forces you to lower the point density or miss data entirely. Also, Livox's ecosystem, while growing, isn't as mature as some legacy LiDAR brands. You might spend extra time troubleshooting driver compatibility or dealing with firmware updates. Let's break down the practical strengths. The headline 450 m range isn't just a number on paper, it actually lets you map large-scale infrastructure from a safe altitude. In a power line test I saw, the sensor reliably detected wires at 350 m while the drone hovered at 120 m, giving operators a comfortable safety margin. The triple echo capability adds depth where single-return LiDAR would struggle, especially in vegetated areas where the first bounce may hit leaves and the second bounce penetrates to the underlying structure. That extra data layer can be crucial for distinguishing between a tree branch and a thin wire, reducing false positives in inspection software. The lightweight nature of the Avia, just under half a kilogram, means you don't sacrifice much flight time compared to heavier sensors that can eat up a drone's payload capacity. The IP67 rating also removes the "don't fly in rain" rule that many LiDAR users have to follow, which can be a real operational advantage in regions where weather changes quickly. Finally, the non-repetitive field-off view means you get a more uniform point distribution across each pass, cutting down on the striping.